Are we live? ठीक है, स्टार्ट करते हैं। स्क्रीन। ठीक है, कल हमने कर लिया ग्रीडी रिकर्जन के थोड़े बहुत क्वेश्चन ट्राई करने थे, राइट? चलिए पहला वाला ही कर लेते, दूसरा वाला लीड कोड है ना, इसको करते हैं। माइट नॉट रिमेम्बर कैसे भाई कोड ऑलरेडी है। Given an integer array, nouns that may contain duplicates return all possible subsets. Must not contain duplicate subsets. Recursion किस मेरे को अभी नहीं पता मुझे रिकर्जन है या नहीं। ये 3 नंबर है, मुझे इसका पावर सेट बनाना है, मतलब 0 साइज के, 1 साइज का 1, 0 1 2 1 2 1 2 2 2 2 2 सेट यूज होगा। इसको मैं सब प्रॉब्लम्स में ब्रेक कर सकता हूँ क्या? देखो 1 2 2 का सबसेट बनाना है, मतलब इधर 1 को लेंथ के बनाना होगा या तो 1 को बिना लिए बनाना होगा। चलो 1 मिनट। रिजल्ट रहेगा करंट रहेगा, ठीक है, एम्प्टी से स्टार्ट हुआ है। मुझे देखो क्या करना है, इस पूरे के सब पावर सेट्स निकालने हैं, सबसेट निकालने हैं, तो मुझे वन उस पूरे के सबसेट निकालने हैं। नहीं यार, क्या 1 को लेके कितने सबसेट बनेंगे, वो 1 को बिना लिए कितने सबसेट बनेंगे वो इंक्लूड करना है। आई डोंट नो कैसे। पहले सॉर्ट कर लिया। सॉर्ट क्यों किया? क्यों प्रश्न? टेम्परेरी वाला हो गया। क्या दे दूंगा? पहली बात तो कहाँ से कहाँ तक का? फिर इसको भेजूंगा करंट वाला। आई डोंट नो कैसे किया यार मैंने। Maybe let's try this one first. Given an array of integers, return the sums of all subsets in the list. Return the sum in any order. अगर ये दोनों एलिमेंट नहीं ले तो 0, पहला एलिमेंट लो, दूसरा एलिमेंट लो, दोनों एलिमेंट लो 5।
Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So today we will be Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So today we will be discussing the problem subset sums from the SD sheet. So before moving on to the problem, if you are new to our channel, please be. If I take 3, 1, 2 as my list of any different type of subset, decide to pick only 3, I'll have set with some 5. If I decide to pick all of 3's, so, and then a 6. So basically the number of subsets that you can generate is nothing but 8. and that is a formula. If n is equal to 3, the number of subsets will always be 2 to the power n. So thereby you can get 8 subsets if you consider the null subset. So you will get 8 subset sums that you need to return. And if you remember, in the problem they expected the space complexity to be big of n. Now for any n, the number of subsets will be 2 to the power n. So the number of subset sums will also be 2 to the power n. So that is why I said the space complexity is wrong, that is given in the problem statement. So this is what the problem expects. You have to return them all the subset sums, and yes, in the increasing order. So that is what the problem is stating. So if this question comes up in the interview, the first approach that you're going to tell the interviewer should be the brute force, and that is basically you have to generate all the subsets. So for that you can use something which is known as power set. Yes, if you don't know about this, I'll be making a separate video for this, and I'll leave the link in the description. So you can use the power set, and the power set algorithm takes 2 to the power n into n time to generate all the subsets, and it does use bit manipulation to generate all the subsets. But this is the brute force technique that you're going to tell the interviewer right at first. Do not jump to the original solution whenever you get this question. So this is the brute force solution that you'll give. After this, the interviewer will not be happy with this extra n that you're using, right? And he'll ask you to optimize it, and then only you will jump to the recursive solution for this given problem. So since Unacademy has sponsored below. So for the optimal solution, you have to write the brute force to generate all the subsets. So one of the possible ways to think is you are having a 3 indexes over here, naming as 0th index, first index, and second index. So if you can decide which index you're going to select in your subset, assuming this is your subset that you are going to have, you can decide which index to select and which index not to select. If you can probably make a decision on it, you will get your subset. Now, for an example, I say I'm going to select this, and I'm not going to select this, and I'm going to select this. So I'm saying I'm going to select the 0th index, which means the third guy. Then I'm saying I'm going to select the second index, which means the fourth guy. So I will get this particular subset. Now again, if I say I'm going to select these 2 guys and I'm not going to select this guy, so that will give me a resultant subset as 3 and 1. So I can say, I can possibly think of a recursive solution which decides to either select or not select a particular index. And if I can do that for every index, yes, for every index, I think I will get my subset at the end. So this is the thought process. And let's see how can we draw the recursive tree for the same thought process. So initially assume you are at the 0th index. Okay, this is the 0th index and you are the 0th index. Now your task is very simple. Whenever you're starting off, you know you will be at the 0th index for which you have to make a decision, and your initial sum will be 0, because whenever you're at the 0th index, till now you haven't decided whether to pick or not pick. So I decide that I will pick this element in my subset. So if I pick this element in my subset, I can surely say that my sum will be increased by 3 because I'm picking this element in my subset. So if I'm picking that, my subset sum, which I ultimately require, will increase by 3. Similarly, if I decide not to pick it, if I decide not to pick that particular index, then my sum still stays as 0. That is for sure. Okay, so I've done that. So if I'm picking this index up, so obviously my pointer will move to the next index. So that is the first index. And over here, if I decided not to pick this index, similarly, my pointer is going to move to the next index where there is 1. So that is what you can do for the 0th index. Either you decide to pick or not to pick. Now, these are the 2 possible calls that you can make as a recursive call. Now, you always know that the left recursion is what is executed at first, sir. Let's execute it. So when you're at this index, right?
जीरो से स्टार्ट करके एन तक जाऊंगा. इसको दूंगा करंट सम कितना चल रहा है, आंसर मुझे दूंगा सेव करने के लिए और एरर दे दूंगा। रिटर्न में क्या आएगा तो आंसर में रहेगा मेरा सामान। ठीक है, अभी यहाँ पे मेरा एक वर्ड सॉल्व मेथड है, ये ले रहे हैं एक इंट इंडेक्स इंट एन इंडेक्स, एक ले रहा है इंट सम, एक ले रहा है वेक्टर इंट आंसर, और एक ले रहा है वेक्टर अरे अगर मैं लास्ट एलिमेंट पे पहुंच गया तो उस केस में जो सम आया उसको रिजल्ट में पुश करना है। इसको फिर नहीं कर देता हूँ कि सारे एलिमेंट कवर हो गए। आंसर में पुश कर दूंगा सम और रिटर्न कर जाऊंगा। नहीं तो अगर उस पर नहीं है तो मेरा दो चीज़ें हो सकती हैं। हाँ, करंट पे तो इसको लूंगा या नहीं लूंगा, दो चीज़ें होंगी, है ना। तो मैं क्या करूँगा, सॉल्व करूँगा, इसको ले लिया है तो वन आई प्लस वन से लेके इसका एन तो एन ही भेजूंगा, सम प्लस पहले बिना ऐड किए किया तो सम विल रिमेन सम। फिर मैं सम में जोड़ दूंगा मैं सम को बाय रेफरेंस नहीं भेज रहा हूँ, बाय रेफरेंस भेज रहा हूँ। सम में जोड़ दूंगा solved it। पायलट चाचा